So this is 3.2 part 2. We're going to pick up where we left off from yesterday. So multiplying with imaginary numbers, when multiplying, here we just have two terms. So I just multiply the numbers together. So negative 3 times 10 would be negative 30. And then I times I would be I squared. And we know that I squared changes to negative 1, and negative 1 times negative 30 would be positive 30. For number 12, since I is being multiplied to the parentheses here, I have to distribute to both things inside the parentheses. So this would be 8i minus I squared. I squared, we know, is negative 1. So negative 1 times negative would make this a positive 1. But we can't leave our answer as 8i plus 1 because we have to make sure it's in standard form with our real number first. So it would be 1 plus 8i. So real part has to come first. For number 3, since we have two terms times two terms, a binomial times a binomial, we have to FOIL. So start by multiplying the first. 3 times 5 would be 15. The outsides, 3 times negative I is negative 3i. The insides would be plus 5i. And then the last I times negative I would be negative I squared. We know that I squared is negative 1, so that would make this a plus 1. So 15 plus 1 would be 16. And then negative 3i plus 5i, it would be like 5 minus 3, so that's plus 2i. We just leave our answer like that with the real number first, imaginary number second. For example 6, this ties back into what we did in 3.1, where we have to solve equations, but here we're going to solve and just end up with imaginary numbers. That's what makes them complex. So if we get a negative number under our square root, that's no big deal. We just take it out and turn it into an I. So solve the same way we did in 3.1. For A, since I just have an x squared, I'm going to move everything to the other side and leave that x squared all by itself. So I'm going to subtract 4 on both sides. So x squared is equal to negative 4. Once my squared part is alone, I can square root both sides. So it cancels out with the squared. So I'm just left with x, and that's equal to, always, whenever you take the square root of both sides, you need a plus or minus. And then the square root of 4, the negative comes out and turns into an I. And then we know the square root of 4 is 2. So this would be plus or minus 2i. So any time we take the square root of both sides, you need that plus or minus there. When we have squared terms, we're going to end up with 2 answers. So we need the positive 2i and the negative 2i. All right, for B, we're going to do the same stuff. Since I just have an x squared here, I want to get that all by itself. So I'm going to add 11 to both sides. So it'll cancel on the left. I have 2x squared is equal to negative 47 plus 11 would be negative 36. Then I have to get rid of that 2. So since 2 is being multiplied to x, I'm going to divide both sides by 2. So x squared is equal to negative 18. And then I take the square root of both sides. So it'll cancel out. So I'm left with x squared, or just x, because the squared cancels, is equal to, anytime I take the square root of both sides, I need the plus or minus. So plus or minus. And 18 is not a perfect square, so we can break it down. 2 factors of 18 are 9 and 2. 9 breaks down into 3 and 3. So I would circle my 3's. 3 comes out. We know this comes out into an I. And then 2 doesn't have a pair, so that has to stay on the inside. So it'd be square root 2. So my answer is plus or minus 3i square root 2. For 7, we're doing the same thing. When it says find the zeros, we just make the f of x 0. Or if it's y, we make that 0. In the other equations on the last page, they were already equations. We didn't have to do anything. But if you ever see an f of x, just make it 0 when it says to find the zeros. So here, I'm going to rewrite it, just make it a little bit easier. 0 equals 4x squared plus 20. We want to get the x all by itself, so I'm going to subtract 20 on both sides. So negative 20 is equal to 4x squared. Then I can divide both sides by 4. So negative 5 is equal to x squared. And then once that x squared is all by itself, I can take the square root of both sides because it'll cancel out with the squared. So then I'm just left with x. And anytime I take the square root of both sides, I need that plus or minus. So plus or minus the square root of negative 5. But I can also simplify the square root of negative 5 and take that negative out and turn it into an I. So this would be x is equal to, I just switched the order, but you can leave x at the end if you want. So plus or minus I square root 5. So that I is still touching the square root. It doesn't go in front of the plus or minus. The plus or minus is going to be the first thing after the equal sign. So it's just the sign in front, but the I just goes right outside of the square root. And I don't know what the square root of 5 is, so I just leave it as the square root of 5. All right, the last 3 we're going to solve. So we have to find the zeros, so I just make this 0. And we want to get the x squared part all by itself. So subtract 7. So negative 7 is equal to x squared. Take the square root of both sides. So x is equal to, anytime we take the square root of both sides, we need plus or minus. So plus or minus square root negative 7. And then we know that negative will come out and turn into an I. So this is x is equal to plus or minus I square root 7. We're going to do the same. So make this 0. I can add 4 to both sides. So 4 is equal to negative x squared. Now before I take the square root of both sides, I need to make it just x squared. So I'm going to divide both sides by negative 1. So this would be negative 4 is equal to x squared. Once the square root is all by itself, we want to get rid of it by squaring both sides. Once the squared is all by itself, we square both sides. So that'll cancel. Anytime we take the square root of both sides, we need plus or minus. The negative comes out and turns into an I. And we know what the square root of 4 is. That would be 2. So this would be plus or minus 2i. Okay, 22. So I change this, make it a 0. I can subtract 1 on both sides, because remember, we're solving for x. We need to get that x squared all by itself. So I have negative 1 is equal to 9x squared. We need to get the x all by itself, so I'm going to divide both sides by 9. So negative 1 over 9 is equal to x squared. Once the x squared is all by itself, we take the square root of both sides, and anytime we take the square root of both sides, we need plus or minus. So plus or minus the square root of negative 1 over 9. We know that the negative comes out and turns into an I. So x is equal to plus or minus I square root 1 over 9. We can simplify square root of 1 over 9 because we know that this is the square root of 1 over the square root of 9. The square root of 1 is 1, and the square root of 9 is 3. So this is x is equal to plus or minus 1 over 3i. And we could put the I on top if we wanted to, or just at the end of the number. So the square root of 1 over 9 turned into 3 once we simplified it.